Okay. So here you go now. 8 o'clock batch will start now. Okay. Last class was a non-technical session. Okay. And the students who are not able to make it to attend last session, you don't need to worry about it. It's just a kind of non-technical session, which you can go through. Okay. The video whenever you have some free time. The regular session was Friday session. So Thursday, Friday, 2 days, whatever is being done was a regular technical session about application and types of applications and creating implementation framework and implementation applications practically. These are the two things so far done in our new batch. Only those two are technical related sessions. Continuation to that, we're going to start tomorrow. We are going to give no break anywhere in between. So we'll continue from today onwards, looking at the technical topics, practicals and all one by one. So to make it as a project. So last class, last technical session, the practical that has happened was creating a framework application, implementation application, right? We will start extending that by adding the features. That means from day one onwards, we are going to start working on developing a new project. Okay, so our project development has started yesterday. The same application we will use going forward, add one by one all the requirements to make it a big project by end of the day, and you will be learning it in a proper connected manner. So if you want to create a new application, how to do it by using a new application wizard, we have practically experienced it. So the next requirement, whatever we are going to do, it's not going to be an independent requirement. It is going to be a requirement that you are fitting into the previously developed feature. Understand? Clear everyone? That's how every day, whatever the requirements you are going to develop, all those are connected. All those are connected to make a project finally. Understand? Okay, clear every one of you? Now we will begin. See, before you start learning the development part in Pega, you need to keep in mind always about the reusability concept. That's a main important aspect when you develop applications or functionalities using any technology. So how reusability can be achieved in Pega? You understood in one aspect that framework and implementation application point of view. If any features are there in framework, you can access those features into multiple implementations because your implementations are created on top of the framework, correct? Suppose I have a framework and implementation A on framework A. I have implementation B, but that is directly on top of Pega platform, not on the framework. So now can that implementation access this framework? An implementation which is not created on top of any framework will not be able to access the frameworks available. It can access only Pega platform, correct? So if you want implementations to access framework features, definitely the connectivity should be there. Means your implementation should be created on top of framework. Understand clear everyone? Now, coming to the point, how to achieve reusability. So conceptually, we need to understand the features or the concepts that are being given in object-oriented programming system. OOPS stands for object-oriented programming system. S stands for what? System. So in an object-oriented programming system, okay, you will be having certain concepts. One more thing is there. Actually, I did not list it out. The another one is what? Polymorphism. That I will teach it later. Okay, not now. So one is encapsulation. The second one is inheritance. Okay, and types of classes is something in the technology. Okay, abstraction. This is called as related to abstraction thing. Okay, encapsulation, inheritance, and abstraction related things. Now we are going to look at understanding about these things. So whatever you are going to understand here, practically you are going to apply the same. Utilize these features there in your application development. Okay, just give me 1 minute, please.
It's very important for me to track the progress.
This is.
If I'm missing any classes, let me know one day prior.
Just give me 1 minute.
I need to update the sheet, which is very important for you to track the progress. That.
Okay, leave it. And here you go now. So encapsulation, inheritance. So first let's start with encapsulation. You need to understand one thing. So what is the difference between a concept and implementation? Concept is just like a blueprint. Concept means it is just like a Blueprint. A blueprint, when you bring it into reality, that is going to make as an implementation. It is going to turn into implementation. See, you have programming languages like C language, Java, C++, Java, Python, all these, right? C programming language is structured programming language. The concept is structured programming language concept. And Java is object-oriented programming language. C++ is object-oriented programming language. Also, you have this one like Python, object-oriented. Of course, structured is possible there, plus object-oriented programming language. Give me 1 minute, please. Okay. So object-oriented programming languages, correct? So now, why those are object-oriented programming means the programming language is developed. See, programming language also someone will develop, right? You need to develop the compiler and all, correct? So programming language when developed, the language structure of development is being implemented by using a concept that is called as object-oriented programming concept. Object-oriented programming system is a conceptual thing. You can adopt that particular system and develop your programming language like Java, C++, Python. You can come up with your own programming language. That programming language has the features that are being told in the OOPS, then that is said to be object-oriented programming language. So in the same manner, we are now going to learn about the concept and equivalent implementation in the programming language. You know, first one is called as encapsulation. What is the first concept? Encapsulation. Encapsulation is group of attributes plus functional components into a single unit. So grouping of attributes plus functional components. I'm sorry. Grouping of attributes plus functional components into a single unit. Without learning these things, you can start working on Pega, but it is not good to do like that. So have the fundamental skills, knowledge, and then start learning tool. Now, see, if you want to learn Pega, the main thing is know the OOPS. Then you start working on Pega, no coding, nothing. Okay. And grouping of attributes plus functional components into a single unit. See, if you want to develop any particular feature like a digital product or maybe physical product, anything. Physical product means it's laptop, AC, TV, projector. Okay, these are all physical products. These physical products have a proper functional behavior. Yes or no? So as a product, if you see laptop is just like whatever you're seeing is a cover. AC is a cover. This TV is a cover. Actual functional components are integrated into that cover. Box. Cover means what? Box. This is just a box. Actual functional components are there inside this box. Correct? Yes or no? So is it only one functional component or multiple? Multiple components are there coordinatively working together. You take example of a vehicle, car, C-A-R, car. Vehicle, car is a vehicle. So it is just like a box, a cover. You are driving car means you are talking about the cover. But what is been the reason for this car movement? Engine, wheels, steering. These are all different functional components coordinatively working together to give a behavior, proper behavior to the outer structure. You feel like outer structure is behaving. You feel like you are behaving. Okay, you are seeing, you are not seeing, your eyes are seeing. Okay, you are not living, your heart is living. You are not digesting, your digestive unit is digesting. So it's you as a cover. Human body, you as a cover, but actual functional components are there inside the cover. So without cover, this will not be having a proper meaning. Correct? So anything you see in this world is being packed. The functional components are being packed. So from human being to all the inventions that you have done, everything should be packed. Inside the pack, you will have all the functional components arranged in a proper order, connected manner. Correct? That's the example of encapsulation. They say that if you are going to develop any programming language, and if you want to say your programming language is an object-oriented programming language, then in your programming language, the functional components that you develop should be packed inside a box. That's what grouping. So that functional components, if you box it, that's a concept of encapsulation. You know, capsule is just a pack. Inside it, chemical composition will be there that actually have the functional features and all, right? Functional behavior and all, correct? Now that's what grouping of functional components into a single unit. Then what about attributes? You're saying attributes. No? So what do you mean by attributes? Suppose if you take AC air conditioner. What is attribute for it? AC has so many functional components, condenser, fan, so many things are there inside that functional components. Then what are the attributes for it? Attributes are, attribute is a kind of value, or you say variable. In programming language, what do you say? Variable. It holds a value which actually impacts the behavior of that class. How class behavior should be will be decided by the attribute holding value. See, your behavior will depend on your BP level. Here BP level is a value, is just an attribute, contains a value. High BP down, low BP down, normal BP stand. Okay. And heartbeat. Heartbeat is related to heart. Heart is a functional component. Heart rate, beat rate, that rate is an attribute. Okay. And AC, the 24, 25 that you are going to set now. So temperature value, that is what the attribute value held by some variable there. So definitely attributes should be there. Okay. Suppose you are taking a loan. When you're taking a loan is going to get processed. What are the attributes in a loan? So many functional components will be there in loan processing. What are the functional components? Calculation of your loan amount, EMI calculator, okay, and validating yourself whether you are fit to take the loan or not. Okay, and these are the things. Then what are the attributes? Salary amount of the customer is an attribute. If it influences your loan or not, it influences. What is your expenditure monthly? What are your savings monthly? 50%, more than 50% of expenditure is there from salary. No, you're not allowed. So credit score, something, another attribute like this. Definitely, if you are going to develop any project, definitely the project related functionalities will be there inside a class. First thing is you need to set up a roof called, encapsulation unit. What is that? Encapsulation unit you need to create. Inside that unit, you define your attributes and you develop your functional components. Understand clear, everyone? That's what you actually have to do when you are working in a programming language or Pega. Without coding Pega, programming language there means coding. Pega means no coding. Now, this encapsulation concept should be adopted by developers of programming language and should be implemented, correct? And they implemented it in Java, Python, and other things. What is the name they have given to it? Is class. What is the name they have given? If I say encapsulation, if I say class, both means same, no difference. Encapsulation is a concept. Class is an implementation of the encapsulation concept. So in programming language, if you are going to write like a class name, open brace, closed brace, that's what box. Inside the box, you have functional components plus attributes. Okay. Now this overall class loan will have a behavior. Behavior will be controlled by these attributes and functional components. Understand clear? That's what programming language concept. So class is nothing new or nothing different from encapsulation. So your building is nothing different from the plan. Plan is building, building is plan. Yes or no? Building is plan only. Building is coming from the plan. Exactly the plan is being made into reality. You got a building, correct? Now encapsulation concept, when you are able to implement it, you implement it as a class. You implement it as a class. In programming language, Java, like that, you call it as class. The same, what is the concept behind this class structure of the class and all? Concept is encapsulation. Understand clear, everyone? Online students, are you clear? Every one of you.
Yes, sir.
Yes.
Okay.
Yes.
So what is the difference between encapsulation and class? Tell me. They both are same, no difference. One is concept, one is reality in the programming language. Concept is been turned into reality. Now scroll down here and see now. See, what are the different classes? So definitely you should create class. See, inside class, you have functional components plus attributes, correct? But you know what? While I was explaining you about the application, theory session about application, I told you that functional components will be there inside an application. Did I tell you that or not? I told you no. Now I am saying today, functional components will be there inside class. Two statements I have given. One is functional components will be there inside application, day one. Day three, I am saying that functional components you create inside a class. So which one is true? Both are true. I will tell you now. Just I will open a diagram to give you idea about this. I'm going to diagrams and application and classes. Application classes. Just give me 1 minute. So I'll find out one diagram. Otherwise, I can draw it. Okay. Application rule sets. Huh? What is this one? This is rule sets related. Huh? I think where I have, I don't know. Okay, I'll draw one diagram. No problem. It's easy to draw. Just simple one. Okay. Just a simple one. See, if this is your application, definitely inside your application, functional components will be there. But those will be created inside a class. So your class will be inside application. Class you are going to create should be placed inside application. So two roofs are there. Roof one outer layer, inside that so many other layers, roofs, and inside that you have different functional components. So how many classes can an application have? It's not only one class. You cannot do it in a single class. You can have multiple classes. I'll tell you the reason why to have multiple classes. Simple thing. You need to think about the real world. In a real world, bank, if you take a bank, in a digital as a digital product, you can consider bank as an application. Entire bank as a application. What you do is you imagine a building. Bank as a big building. One building is there. This entire floor. In a building, what you have in a floor, you have so many rooms. Correct? So just imagine the entire building is a bank. Correct? So inside the bank, you want to have different departments being set up. Yes or no? See, inside a bank, you want to process banking operations, loan operations, insurance operations, credit management operations, and maybe other different other type of operations also. So all these operations will not be done by a single team. Will not be done by, it's not that you will have a big space and then everyone will be sitting there and working. So they will divide into different teams. See, there is a big building which is called bank. Inside that there are small rooms. Okay, room one, they are saying it as department. One department. Department one is responsible for banking operations. So inside department one, what is the functional processing being done? Banking operations. Department two means another room you can imagine. Department two, inside that, loan operations. Department three, insurance operations. Department four, credit management operations. Like that. Department five, dispute management operations. Like that, different operations will be done by different departments. Why should they divide into different departments? Why not everything at one place and ask them to do it? Just think about it in the real world. What is the reason for having different departments and all? Okay. Ease of delivery. Other than that, finding customer is okay. Customer can find is okay. Other than that, for a business, what could be the advantage if they divide into different departments? As a business, why you have to divide? See, you can ask a big floor, everyone sit here and do it. They can do. So what are the advantages having like this?
Ease
Manage.
of
Easy to
management.
maintain, and manage. So the business is easy to manage and maintain. Okay, a simple example. Maybe I don't know whether I have told this before or not. You have different dresses to wear. Like you have party wear, you have ethnic wear, and you have casual wear. You have formal wear, official office wear. Okay, formal wear. So these are different categories of dresses you have. Everything you can just put it as a heap. So suppose you take a cupboard, everything you can just place it as a heap. Is it easy to find a specific type of dress or difficult to find? Ultimately, you'll find, but it is easy or difficult? It is difficult. It is not only difficult for you. Suppose one day your friend came, he is requesting that I want to go to a party, give me address, I like it. Okay, then you just told him, go and take from that cupboard. He has to spend one day, party will be over. Right? Okay, now it's difficult to manage and maintain. And it is difficult for a stranger to pick the right one. Correct? Now, when you divide it, segregate your cupboard into 4 racks. Rack 1, rack 2, rack 3. Party wear, one label. Okay, office wear like casual wear and ethnic wear. Like that, 4 racks you arrange different dresses. Now your friend came asking for party wear. Go and take from that cupboard. He'll be able to take it within just 1 minute. Right? Even you or others also, newcomers into project, they can easily find out what is there where. Correct? So that's the way. So it is like, it's called as modeling. The concept is called as modeling concept. We'll come to that again. But example, you understand, right? So it's easy to maintain. It is easy to manage the things when you divide into different departments. Do not club everything into one particular thing. Okay. So when you have when you have a bank, as you are dividing into different departments, the same when you turn into a digital product called as application, definitely this depart. So bank you created as an application. Department, how do you set up? It's another roof, no? Every department. Inside department, you need functional components, correct? So the department is equivalent to class. So now 2 things you have to set up. Application setup, classes. Is it possible that you identify all classes on day 1 itself? May not be. So whatever you identify initially, create those things, arrange those things properly. And in the future, if you want to enhance, you enhance. Okay. Now, so that's what an application is going to have multiple classes. Each class will have its own functional behavior meant for some reason. Each class will have functional components plus attributes. So our next practical, you can guess, if you are able to guess now, what could be our next practical? Creating class. Creating class. After creating class is over, what could be the next practical? Creating attributes plus functional components. You understand what we are going to practically implement soon, right? But classes are already created automatically when you create new application. I will show you that. Okay, I'll show you soon. Classes are already created. We'll practically see how to create manually. Okay. And next topic is, see, you are dividing into different departments, correct? So now when you divide into different departments, here the functional component which is available at a class may be needed for another class. One department functional component may be needed for another department. I'll tell you an example. See here. Now, if you look at this example, bank application has account department, loan department, credit department, card department, verification department. So out of these 4 departments, account is independent, loan is independent, card is independent. Okay, but verification is a common department for accounts, loans, and cards. You want to give a new card, you need to do verification. You want to give a new loan, you need to do verification. You want a new account opening, you need to do verification. So verification department functional features are pretty common for every other department. Means one class features are required for other classes. See, I don't want to create 3 times the verification functional component. One time I want to create verification functional component. I want to reuse it in many places whenever I need. I just make a call. Then verification functional components needs to be utilized at n number of places. That's called reusability. No? How do you achieve such a reusability in technology? That is with a new concept called as inheritance concept. What is the concept called as? Inheritance. Inheritance is a universal concept. Encapsulation is a universal concept. Class is a concept in Java, Python, C++, like that. Okay, implemented from universal concept of encapsulation. Now, inheritance universally, if you want to learn. See, the best example for inheritance is our family structure. Family structure in a family. Okay, in a human family, we have parents and children. Parents have parents. Those are grandparents. Grandparents again have parents, great grandparents. Like that tree structure you can see. This is the example of inheritance. Whatever the property that your father has earned, you are allowed to use it. You are allowed to, you can access it because you are inherited by blood relation. And your father property also, you are allowed to access. Forefathers property you are allowed to. That's how you are getting the property since long back. Correct? Okay, from the higher level starting, you are getting your property being given to downward. This is inheritance. Inheritance is a relationship defined between two classes as parent and child. Inheritance is a relationship defined between two classes, making one of the classes parent, another one as child. The common features, one is parent class, specific things are children. Understand clear? So when you are thinking about inheritance, how can I utilize the features of a one class accessible to multiple classes? You need to define inheritance relation between the classes, where the common features class, you just place it at the top level. You place it at the, in a tree structure family, your father is at top level, you are at bottom level, same way. A class at top level and bottom level. From this class, child 1. From this class, child 2. From this class, child 3. Like this, you can create a number of children for one class. So class A, something is there. Class B inherits from A, means class B is child class of A. A is parent, B is child. And this is called inheritance concept. B can access the features that are available, attributes plus functional components of class A. The advantage to have inheritance being implemented in your project, the advantages are reusability, easy to extend, easy to maintain, and cost effective. The same things as we discussed by using framework implementation application. Framework implementation application is also framework parent application implementation child. That is also concept of inheritance between applications. But here concept of inheritance between classes. Both are necessary. Okay. Make sense clear, every one of you?
Yes.
Okay.
Yes, sir.
Now, inheritance can be two levels. Okay. Actually, you have hierarchical, many things are there. I'm just telling you about only two levels in object oriented. One is single level inheritance. Second one is multi-level. Parents and children, single level. Grandparents, parents, children. Great grandparents, grandparents, parents, children. This is called multi-level. From this, what you need to understand is a lower level class can access the features of its higher class plus higher class of higher class, means parent class, parent class, parent class, parent, parent, like that, n number of levels it can access in a chain. This is clear, everyone? Generally, inheritance means class A, class B inheriting from A, B is child of A, class C inheriting from B, C is child of B, B is child of A. C can access B as well as A. That's called multi-level inheritance. Like, you don't need to think about technical aspects. Just look at your family and how you can get the property from your father, like that same thing, concept called multi-level. Only you see yourself and your father, that is called single level. See your father as well as great grandfather, great grandfather, multi-level. Understand clear, everyone? These concepts are being implemented in a technology as, again, same name, inheritance only. Name is inheritance only. In technology, name is inheritance. OOPS also inheritance. In OOPS encapsulation, technology, it is class. In OOPS inheritance, technology also inheritance only. Naming convention is not changed. So you need to identify the common functionalities, place them in a class. That class you make it as a parent and derive the child classes for that. That's what you will be actually doing. Okay. We will experience these things practically while we are going to work on it. Understand clear, everyone? Online students, are you clear?
Yes, sir.
Okay.
So, sir, class and function are both the same?
Class and function is inside class. Functional component. Laptop is class. Inside that, hard disk is functional component. RAM is functional component. Processor is functional component. Car is a class. Inside that, steering is functional component. Engine is functional component. Gearbox is functional component. Like this. Understand clear? Make sense? Are you clear? Someone who has asked this doubt.
In function also, if you see in real, I mean, like in technology, right? Suppose let us take a database function or anything. There also we declare a variable. If you want, we can call another function.
You declare a variable inside function. Where is function? Inside the, means variable is ultimately there inside class. If you talk about the scope, that's a different concept. Okay, scope of accessibility is a different concept. But function is inside class means variable is also inside ultimately. Class or not? Are you clear?
Yeah.
Okay.
Yeah.
Okay. Let's go ahead. See, before we proceed to discuss about types of classes and all, let's discuss about organization structure. This is just a concept that we use in Pega. See, generally you know about organization, correct? What do you mean by organization? It's a company. Okay. So I say that organization is a topmost business entity. What do you mean by topmost business entity? I'll tell you an example. You take a business entity like Tata Industries. Tata Industries is topmost business entity. It has so many other divisions. It has so many divisions. What are the divisions? Tata Information Technology is a division. Okay. And Tata Metals is a division. Okay. Tata Auto is a division. And each division can have units. Each division can have units. Tata Information Technology. What are the units? TCS, Tata Consultancy Services, where actual operations will happen for information technology. Maybe other companies are also there. Tata ELXI, something. Other companies are also there. Okay. Next. Tata Metals means Tata Steel is there. Tata Steel Industry is there, where actual production will happen. Divisions will supply necessary components. Production is actually happening at units. And what is the third one? Tata. What did I tell you? Auto. Tata Auto means you have Tata Motors. Tata Motors. Again, in Tata Motor unit, subunits can be there. Nano, okay, and commercial vehicle, personal vehicle, like that subunits can be possible. Okay. So generally, typically an organization structure is going to have 3 levels. Typically, organization, division, and unit. See, another simple example I will tell you for your ease of understanding. Suppose you take a filmmaking industry, filmmaking production house. A production house is an organization. They are going to make a movie. But movie, when they make it, the transactions are like revenue generating from movie will not happen directly in the production house. That means you go to production house and ask them, I want to purchase a ticket to watch the movie. They won't sell you. Okay. The movie they produced, they are going to give it to distributors. Second level. Production house, distributor also, they are not going to sell you any tickets. Now they will send the boxes to theaters. Theater is a unit place where actual business transactions will run, sales will run, that will make money. So from top level to bottom level, it is being accessible. At the very bottom level, actual business transactions are happening at unit level. Understand clear, everyone? So that's what you can even take the example of car manufacturing. In any industry you can see in real life. Organization is topmost business entity. It will have divisions. Divisions will have unit. This is the structure you will see everywhere worldwide for any business. Yes or no? What you really see in the reality, the business structure, same you have to achieve in the technology also. See, let me tell you one point. Technology, when they digitalize your business using any technology, it should not have its own structure. What is the structure that is there in the real world for a business should be digitalized into digitalized by using a technology. So when you are learning about technology, definitely organization structure you have to follow. We have already created organization. You remember that? We created. But divisions, we did not give separate names. Division name div, unit name unit we gave. But out of these 3, unit structure is the one where actual business transactions will be running. This point, are you clear? Then what does organization and division will do? It will supply reusable components to divisions and unit. In such a manner, organization, division are parent, unit is a child. It is the very bottom level is the one where sales will happen. I mean, like the transactions will happen. Keep this point in mind. We'll discuss about this again. Okay. Are you clear about general basic information about organization structure? Everyone. Okay. If you're clear, I'll take you to the next one. Next universal concept in programming language. That is, one more thing is there. OOTB classes. I will take it. See, let's relate the things to Pega OOTB. You know what do you mean by OOTB? What do you mean by OOTB? Out of the box classes means Pega rules process commander environment has one OOTB application, correct? What is the application name? Pega platform. It has OOTB functional components. I have shown you one functional component, you remember? This functional component I have shown you. No? This functional component is there in a class. Its name is @base class. See, I already told you today that functional components will be there inside classes. Classes will be there inside application. This structure even should be followed by Pega systems, correct? Pega systems, when they are providing you OOTB functional components, definitely those functional components would have been created in one application, that is Pega platform. But directly application doesn't contain components. No, application will have classes. Classes will have functional components. Understand? So Pega has some OOTB classes. Pega has some OOTB classes. Out of, you can search here if you want to search. @base class. There is one class called as. See, Pega also maintains its OOTB functional components into different classes, not only one class. Some components in class 1, some components in class 2, some components in class 3. Again, inheritance relation will be there between the classes. It will also think about reusability when it has provided us OOTB features. Out of which the topmost class in Pega is what? @base class. @base class is the topmost class in Pega, which means it is parent class of every other class in PRPC tool. In PRPC, you have 100 classes. For all 99, the parent is ultimately base class. You created your own 100 classes. For all your 100 classes, ultimately top level root will be base. Every class you create, every class that exists in Pega, the root class is @base class. It is only not @base class. There are other classes also OOTB important classes by name we should know now. Below base class, next level, second level, these are the OOTB classes. Work dash hyphen is there, no? That you need to read as dash. Give me 1 minute. I'm going to copy this and I'm going to paste it. There is one class in Pega called work dash. Okay, if you go to @base class and below this @base class, you see somewhere work dash is available or not. See, immediately under base class, next level, you have work dash, system dash, rule dash, Pega agile dash, okay, log dash, link dash, int dash, like this. So many classes are there. So many are there. There are so many other classes are there. So work dash, important classes I'm going to write. Data dash, index, okay, int dash, okay, code dash, rule dash, system dash, index dash. What else we have? Embed dash. Just give me 1 minute. Important things. Assign dash and link. We will come across all these things. That's why I'm telling. Assign dash, link dash. We will come across all these things, etc. So the important classes just below base class, Pega provided class. What will be there inside this class is not a question. We'll come to know soon. Okay, when we are practically working on it. But I'm just giving you the levels. Base class, below that, work dash, data dash, int dash, code dash, rule dash, system dash, index dash, embed dash, assign dash, link dash. The class name itself has dash. Class name itself has hyphen that you read in Pega as dash for your information. OOTB functionalities that are available in Pega PRPC tool are available created in OOTB classes. These OOTB classes are part of Pega platform application. Are you able to get the architecture of Pega? Application Pega platform, inside that OOTB classes, some OOTB functionalities. Same way, our application will have classes, our application classes will have functional components. Make sense, clear? So we are going to learn how Pega has developed its tool. Same way we are going to learn. And next topic is types of classes. What is the next topic? Types of classes. This is very, very important to understand. Even though you don't have the knowledge, you will be still able to work on Pega. But it is always good to have knowledge before you work on it. Just give me 1 minute. I'll copy from the previous class document. Okay, just give me 1 minute, please. This one I copied. Types of classes I forgot to copy. Okay, advantages of inheritance, again, same thing, reusability, all those. Okay, now this one I'll be able to finish up to here. But I don't know whether I'll be able to do it or not, but let me take it. Okay, types of classes. Next topic is types of classes. I did not copy everything or what. Types of classes. This is fourth one in our order. No? Okay, there are two types of classes exist. See, class as a structure they provided in programming language, right? So you create without writing code in Pega, but again they have categorized classes into two categories. What are those? First one, abstract class. Second one, concrete class. First one is abstract class and the second one is concrete class. What do you mean by abstract class and what do you mean by concrete class? I'll explain you. See, if you remove the words abstract, okay, before we proceed further, do you have any doubts or questions? So far, are you clear? Everyone who has connected online and offline, are you clear with everything that I'm trying to explain you?
Yes, sure.
Okay, good. Thank you. And types of classes, information point, abstract and concrete classes, two types. Okay, just I want to show you in the Pega environment. Suppose if you right click on a class and go to definition, you see here, you can choose one of these two options when you are manually creating. I'll show you that. Okay, but Pega automatically creates also, it will choose something. So there are two types of classes available, abstract and concrete. Suppose if you remove that word abstract, if you remove that word concrete, what is remaining? Class is remaining. So whether it is abstract or whether it is concrete, it is a class only. Class means attributes will be there, functional components will be there, correct? Then what is the difference? Both classes, abstract and concrete, both will have attributes plus functional components. But the thing is, in an abstract class, abstract classes are meant for, okay, in an abstract class, we cannot, remember this, we cannot initiate a transaction. This is the real need in the real world. It's a need in real world. I'll tell you. See, you have different departments. I told you, loan department, accounts department, card department, verification department. Loan department is meant for initiating transaction of a loan. Yes or no? And account department is initiating a transaction of deposit, withdraw, like that. And insurance department is responsible for initiating a transaction of insurance policy processing. Is verification department responsible for initiating any transaction in the real world? It participates in between the transaction processing. Yes or no? By sharing some components for verification purpose. Sharing some components for verification. You do not initiate any transaction in a verification department. In the real world, you go to a bank and go to a verification department, ask them, can you please initiate transaction for loan or any other thing? They will say that we are not authorized to do that. Go to the respective department, they are authorized to do it. Means the department has an authorization. Whether they should be able to do it, they should not be able to do it. Restriction is applied on a class. Both are departments only. Verification is a department, loan is a department. But verification department is marked as abstract department. That's why they don't have right to initiate transaction. They are human beings. They can just understand whatever you say and they follow it. Technology cannot follow it, right? You need to apply the restriction in the definition itself. In the definition, when you create a class, if you mark the class as abstract, then if you try to initiate a transaction, it will stop you and say that you cannot create any transactions here because it is marked as abstract. If you want a class without a transaction initiation feature, like verification department turn it into a class, you need to create it as abstract class. You need to create that as abstract class. Abstract class will have attributes plus functional components, but transaction cannot be initiated. Concrete class, attributes plus functional components plus transaction can be initiated. Transaction can be initiated. In a real business, do we need both department, abstract plus concrete SR? Definitely, there is a role of each of those. Abstract departments are must, concrete departments are also must. But must means optional. Abstract is optional. See, frankly speaking, without abstract, only concrete, it is possible to run the business. But without concrete, no business at all. So though it is optional, that is a need to have abstract departments in the real. That's how in our application also, we'll create classes. While creating based on its nature, we will be able to understand whether we need to create an abstract class or concrete class, and accordingly we'll create. So difference at a high level, difference between abstract and concrete. Abstract classes cannot be having transaction initiation feature. Concrete classes, we can initiate the transaction. We'll practically see that. Okay, we'll try once, it will stop automatically. Okay, and now see, usually abstract classes are parent classes. They will occupy, these will occupy parent class level. Concrete classes usually will come at the bottom level. If you compare organization structure, organization, division, unit. Unit is abstract or concrete? What do you think? Unit is concrete. Why? Because transactions will happen at unit level. I told you, no? So definitely if you are turning that unit as a level, unit level as a class, if you're creating a class at unit level, definitely that is going to be concrete. Organization, division, abstract only. Organization, division, abstract levels, and unit is concrete level. Understand clear, everyone? So if you have any doubts or any questions, you can ask. Division is also abstract. See the very bottom level. It's, you can simply understand. I told you an example. Suppose if you are going to car manufacturing company, ask them to purchase a car. They will not sell you. So from there, just you have reached a distributor. Ask him to purchase a car. He will also not sell you. So, but you go to outlet in your city. Ask them, I want to purchase the car. They will initiate transaction because they are allowed to do that. Remaining above levels, supply will come from above levels to below levels. Correct? They are parent. This is child. They'll supply many children. Right? So transactions will happen only at the bottom level. So if you are setting up this digitally as a classes, you will have units as concrete classes. Division and organization are abstract classes. Division and organization are abstract classes. Understand? That same we are going to practically see in our development also. Okay. Are you clear so far? Division is child of organization. One or more divisions will be there. Units are children of division. Units can access from division as well as organization. Division is, yeah, you see, you want to create division level as concrete, you can create. But in the real world, division is concrete or abstract. Abstract. So your technology also, you are going to create a digital product, which is a replication of the physical asset, correct or not? Are you going to create by your own, or you are going to, so first physical business or digital business? Business as physically it exists, operations will happen. What is there physically, you are going to translate into digital product. It should exactly match, or it can be different way. It should exactly match. When you exactly match, divisions will become abstract only. So your digital product are all just like whatever you have physical business operations, a replication, that's it. Okay. And here you go now. So tomorrow we are going to discuss about inheritance in Pega. What is the concept? Inheritance in Pega and its types in Pega. So it will take half an hour time. This will alone take half an hour time. Inheritance, you understand, right? Inheritance and multi-level, single level, you understand. That will never change. That's universal. If in Pega also, the concept will never change. But in Pega, how they are achieving this inheritance concept? In a tool, how they have implemented. Tomorrow, at the very beginning, I will show you the classes created in our application. We need to examine what is being created by default. So you created a new application. You need to have an examination on what is being created and understand what is there. Suppose if I give you laptop, simply directly you cannot, okay, if you get a car or bike to you, your hand, a new bike, you're already a bike rider, suppose. You got a very brand new bike, another model which you have never used before. What do you do first? Simply you use it or what? You just need to know different features of that. After you know where is brake, where is clutch, where is gear. So all these things you examine, know about each of those, then start using it. Correct? Correct? Same way, you created application, okay. Blindly, you don't start, start implementing the thing. Examine what is being automatically created by the wizard. Okay, in our application, certain things are created automatically. I understand, okay, these are available. I can use this for various purposes. And then I'll start my practical, correct? The same way. So the class is created automatically by application wizard. By application wizard, we need to do just an examination of those things. Once we got it something, and then we'll discuss about inheritance concept and its types. Once this is over, we are good to discuss about the rules which we need to create in order to implement the functional requirements further. Okay. So tomorrow, half an hour will be theory related to OOPS concepts, how they have implemented in Pega. And post that, next half an hour will be introduction about not practical. Before you do practical, you should know something to create, right? Because classes are automatically created. Otherwise, you would have created a class practical. I'll show you class practical also. I'll show you just like that. Okay. Okay. And not for a real need. Just like that, I'll show you class practical. Then functional components and attributes you have to create. So before you create functional components and attribute, so what are the things provided to create functional components and attributes in Pega? You need to know about those things. So that I will explain you. So tomorrow 1 hour is also theory. Half an hour is related to extension of OOPS concepts, and half an hour more is related to rules in Pega, which are needed for implementing some functional component features, some features. And then day after tomorrow will be practical. Again, theory, practical, theory, practical, but all are going to be in the same application. Okay, not separated, same application. Okay, like a practice, like project you have to do. Are you clear so far, everyone? Any doubts or any questions?
You can say abstract class can inherit property from another abstract class.
Of course. An abstract class is going to be child of another abstract. Concrete is going to be child of abstract, like that.
Harsh, the classes, right, that work, data, and that the class type depends on whether it involves transaction
See,
or not.
all Pega classes are abstract classes at a higher level. Pega also will have these levels, right? Pega has certain number of levels. Very bottom are concrete, remaining all are abstract. Same as what we have discussed. Work dash, data dash, all these are abstract. Base class is abstract. At the very bottom in that structure also, some concrete we will see for storing the things and all that. When we come across, I'll tell you. All the class names, whatever I have shown you, are abstract only. Don't by heart those things. Just know it and leave it. When you are started using those things, automatically you can remember. Okay. Child class can access the features from parent, but not vice versa. Yes. What's your question? But not vice versa. So legally, you have right to access the property of your father, but reverse is not there, no, generally speaking. Okay. So the same way technology also been designed. Child class can access the features of parent, but not vice versa. Okay. There is no relation between two classes. Suppose, is there any possibility of accessing the features of one class to another class? That means you can understand one thing, without inheritance relation being defined, you cannot access the features of a class to another. Understand? Okay.
Hello, sir.
Yes,
I
please.
have a query regarding the abstract class and concrete class. So generally in programming languages, in abstract classes, we usually just define the method or just declare the method, and we do not provide the complete implementation. And is it similar in case of Pega 2? We just don't, we just declare the method or functional
No.
component, we don't implement it.
So for your information, we can create function definitions also in abstract classes in latest versions of Java. Okay, for your information. It is possible today. And it is possible even in Pega, you can implement it, but you don't execute it at that place. Access it to concrete and then make it executable. Okay.
Oh, okay. Got it. Probably this will be much more clear after we do the practicals. Thank you.
Yeah, see, it is very simple. You cannot execute to make transaction. In abstract means there is a restriction, cannot initiate. That's what in the technical definitions in textbooks you will study these things only, right? Abstract classes cannot be instantiated. Concrete
Okay.
classes can be instantiated. In your textbook, you find it, no? So what is the meaning of instantiation? Ability to initiate a transaction is not there for abstract. Concrete, the ability to initiate a transaction is there. That I will practically show you. Okay.
Got it. Thank you, sir.
Okay.
Can make base class according to our
See, anything OOTB provided can be customized as per our need without writing code again. Without writing code. Whenever we need such customization, we'll see. Okay. And that's it for today. And we'll meet tomorrow. Tomorrow also free meeting link only will work. But from day after tomorrow, free meeting link will not be working. See, those students who are yet to make the fees payment, I request you to kindly complete making your fees payment max by today evening or max by tomorrow evening. Max by tomorrow evening. And after tomorrow's session, if the admins are going to announce that meeting link has been changed, they won't provide you the new meeting link at all. So after you enroll only, they will provide you. So just please act on it. You have already attended enough number of free sessions, correct? Okay. So this is pretty much fair enough to decide whether to continue or not, or maybe whether it fits for you or not. So today's session, you have to go through it once again, draft the important points in your notebook while you are going through it. Okay. Only the key points you draft it, not everything. Okay. That's how you make your own notes only with key points. Then it will be easy for revision. Okay. If you are writing everything I am teaching again, that will be a big deal for you. It will not be useful for revision. Don't. So try to draw diagrams when you are going through it. Okay. So you don't have to really rewatch the video. You just need to go through this class running notes document. You'll understand everything. You will be able to recollect. These are the key points actually. Okay. For your reference, you can note down in your notes. And just to contact the admins, they would have shared you fees payment details from the number 9652532753. What is the admin number? Okay, 965253. You should save this in your WhatsApp phone, and they would have shared you details about account details, Google Pay, Phone Pay, and all. You can accordingly follow up with them. Once you do that, they will immediately send you one message about asking you to fill a Google form. Some of you might have received it and you would have filled it. After you fill the Google form, they will send you two links, Google form link, classroom link. Ask you to fill the form as well as register into, enroll into Google Classroom to access the documents. These two things will be done. Apart from these two, once your registration is over, they will give access to the drive. That they will do it on Friday or Saturday. Okay, till then we'll post in YouTube only. Thursday, maybe Wednesday we'll post tomorrow. Thursday, I don't know whether they will post or not. They will add into drive and give you drive access. Okay, only to the enrolled student. And these are the steps. You need to act upon two things: filling the Google form, joining into Google Classroom for documents access purpose. Documents storage is separate. Video storage is separate. Document storage is Google Classroom. Video storage is Google Drive. Access will be separately given to enrolled students only. Documents video will not find at one place. Understand clear, everyone? Okay, keep this in mind. So once you send them the things, after a few minutes, you will receive a message. So just have a look at the message that they are sending you personally. Okay. And two links will be there, form link and classroom. Fill the form, join the classroom, and then they will generate a student ID and give it to you. They will pin it in your WhatsApp message. Okay. That student ID, you should use it as you start attending regular sessions. So I'll tell you later about the student ID. For today, we can wind up. We'll continue tomorrow using the free meeting link. Thank you for joining, everyone. I'm going to close the meeting.